Okay, this is a video for 10.4 for Math 2 for rational exponents and radicals. So this reiterates what we've been looking at in previous sections. We're just going to finalize it. So if we have a base to a fractional exponent and the numerator has a meaning and the denominator has a meaning, we saw that the denominator creates a radical, an nth root radical. So if it's a 2, it's a square root. If it's a 3, it's a cube root. If it's a 4, it's a fourth root, etc. The numerator is going to be just a regular old power. And I want to give you an alternate way to write this. You can also think of this as the nth root of b, then take it to the mth power. So you don't have to do the b to the mth power first. You could do the mth power second. And most times this is actually more useful to do it this way, to take the root first, then the power. But it could be done either way. So let's do some examples where we have to simplify each without a calculator as much as we can. I'm going to have you write down some common powers to help us. So for example, I'm not going to write down all the squared ones because those are ones you're used to. But let's do some cubed ones. So like 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, and I think after that I don't remember them off the top of my head, but I will tell you that 10 cubed is easy. 10 to any power is easy because you just write a 1 and then the number of zeros. So there's 3 zeros because it's a 10 cubed. So you could do like 10 to the 5th. Just write a 1 and 5 zeros. Okay, so that's 100,000. Let's write down a couple common fourth powers. So 2 to the 4th power is 16. 3 to the 4th power is 81. 4 to the 4th power is, what is 4 to the 4th power? I believe that is 256. And 5 to the 4th power is 625. And they get pretty high pretty quick. I think that's good enough to get us going here. Okay, so let's start by rewriting 8 to the 5/3 power in this form. So that would be, well, the denominator is a 3 and the numerator is a 5. So this would be the cube root of 8 to the 5th power. So we're taking a cube root because of the 3. All right, a cube root of 8, well, 2 cubed is 8, so the cube root of 8 is 2. So we're taking 2 to the 5th power. That is another one that we should list somewhere. 2 to the 5th power is very common. It is 32. So this is 32. Let's try B. So this would be the 5th root of negative 32 being taken to the 2nd power. Again, the denominator right there. The numerator is going to be right here. So the 5th root of negative 32 is what times itself 5 times gives you negative 32. Well, 2 to the 5th power is 32. But negative 2 to the 5th power is negative 32. With odd powers, the negative is okay. With even powers, that's something that's not going to work. All right, and then we're squaring it. So negative 2 squared is 4. So why don't you pause the video and try as many as you can for the rest of these here. And then when you're ready, unpause it, and then we can look at the answers. All right, let's take a look at some of these answers. So for C, we had negative 8 to the 4/3 power. So the denominator is going to tell us to make a cube root. Then we are going to use the 4, which is the numerator, to take it to the 4th power. So the cube root of negative 8 is negative 2. Negative 2 to the 4th power is 16. All right, D, we have 25 to the 3/2. 2 is a square root. Now, we don't usually write the 2. But you can pretend that it's there if you want. And then we're going to cube it. All right, so the square root of 25 is 5. 5 cubed is 125. All right, E, you might have needed a calculator for the last part. First off, we are taking the 4th root of 625 and taking it to the 7th power. All right, so then the 4th root of 625 is 5. 5 to the 7th power is, I don't know. That's a big one. I don't know that one on the top of my head. So, well, this calculator can't do exponents, but you would do 5 to the 7th power. 4, 5, 6, 7, 78,125. It's a big number. Okay. F may have looked intimidating, but since it was a 7th root, and remember I told you that with powers of 10, you can just count the zeros. This had 7 zeros. That told us that the 7th root of that number is 10. Then we are going to cube it because that was the numerator. And so that would be 1,000. The last one here, G, we have to take the square root. All right, so that's why we don't write the square root of negative 16. That is not possible because there is nothing squared that would give you a negative number. Not 4, not negative 4. They would both give you positive 16 if you were squaring them. So this one is not real, not a real number. Later in the year, we'll discuss imaginary numbers, which is what this is. Okay, let's just do a couple more examples here. Applying some of the other rules that we've learned. So we have a product inside, so we're going to take 27 to the 1/3 power. And then we have c squared to the 1/3 power. 27 to the 1/3 power is the cube root of 27, which is 3. C squared to the 1/3 power would be c to the 2/3 because we're going to multiply. Here, this is a little weird. We've got 8x to the 1/4 power, and you'll notice it's multiplying by itself 4 times. So what if we wrote it as 8x to the 1/4 power to the 4th power? So then we have a power to a power rule. 8x to the 1/4 power, so would be, well, 1/4 times 4 is 1. So 8x to the 1st power will be just 8x. All right, let's look at number 3. Write each in radical form. We have x to the 2/3. Well, radical form is this form right here. This is exponential form on the left. And this is radical form on the right. So x to the 2/3, well, that 3 and that 2, the 3 tells us that it's going to be a cube root. And then we're going to have, we can either write it as x squared or we can write it as the cube root of x all being squared. Last example here. That would be the 5th root of y to the 8th, or the 5th root of y all being taken to the 8th power. Okay, and we're done.